Okay, question 3, quite a nice pulley question as they go. Caused a little bit of confusion with some people, so it's worth blasting through it. Okay, so P's got a mass of 0.4 kilograms and it's sitting on a table. It's a rough horizontal table, so there's going to be some friction, which they tell us about. And it goes over a pulley, and the other end is attached to a ball Q of mass M kilograms. That's a weird M, sorry. Okay. That's a capital M in fact, don't worry too much. Let's go. Q moves down with acceleration 2.5 meters per second squared, which means P is going to move that way with an acceleration of 2.5 meters per second squared. P doesn't reach the pulley, Q hits the ground. Okay, and we need to find the tension in the string. Okay, I got a bit confused. I thought it was going to be all over the place, but it's actually a lot simpler than it looks. If we just look at an equation of motion for P, so F equals ma. We look at P. Okay, yeah, it's got a weight and a normal reaction. We don't really care about those, but we can put them on 0.4 g, and the normal reaction will also be 0.4 g, because it's not moving through the table, it's not floating off into space, and there's nothing else pulling it up or pushing it down. It's got a tension pulling it that way, and it's got a resistance force pulling it that way, and it tells us the resistance is 1.5 newtons. Okay, so the resultant acceleration is in that direction, so the resultant force is T minus 1.5. So T minus 1.5 equal to the mass, 0.4, times the acceleration, 2.5. Okay, so T minus 1.5, 0.4 times 2.5 is 1, so T equals 2.5 newtons. That's it, that's all you needed to do. Okay, it's that simple. Okay, and then next part of the question, I think it's part 2, find the value of M. Okay, so then if we do an equation of motion for Q, okay, Q has got weight on it, mg, and it's got tension of it, and we know with tension now it's 2.5. It's accelerating downwards, so resultant force is mg minus 2.5. So mg minus 2.5 equals the mass m times the acceleration 2.5. Okay, so g is 9.8, so we get 9.8 m minus 2.5 equals 2.5 m. Okay, so we get 7.3 m equals 2.5, so m equals 0.342. I'll leave it at 3SF, maximum 3SF, remember when you're using G, so 0.342 kilograms. Okay, right, find the time after release for Q to hit the ground. Okay, so we're moving into SUVAT territory now. So part B, we know it starts at rest, so U equals 0. We know that it goes down 2 meters, so S equals 2. We know the acceleration is 2.5, and we want the T. Okay, so we're using S equals UT plus half AT squared. So we get 2 equals 0T plus half A, so half A is 1.25. T squared, so 2 divided by 1.25, and then square rooted. So we get T equals 1.26 seconds. Alright, state one limitation of a model which will affect the accuracy. Could say the string could be extensible. The most common one would probably be to take account the action of friction in the pulley, so the pulley probably wouldn't be smooth. Okay, you could say you could take into account air resistance on Q and on P as well. The one I would put personally in the exam, the weight of a string is another one. I would always go for the pulley. In reality, the pulley wouldn't be completely smooth. But any of those is fine. Okay, weight of a rope, friction of a pulley, air resistance on P and Q, that sort of thing.